if you would get out your worksheet, which is titled 10-2 Practice Problems, we're going to look at some of our one-step and our two-step problems. You might want to have your notes handy to refer to, as I will be referring back to some things that we wrote down in that section. Okay, so in number 1, it says find the mass of 0.89 moles of calcium chloride. One strategy that I strongly encourage each of my students to use is to highlight or underline your knowns and your unknowns. So it says 0.89 moles of calcium chloride. That's definitely important. And then it wants us to find the mass, and we know mass is grams. All right. So in the notes, we said that if you see moles, you know that it will be a one-step conversion. And we also said that if you see mass mentioned in the problem, that you're going to need to find the molar mass of the substance. Let's begin by setting up our problem using dimensional analysis. So we have 0.89 moles, and this is of calcium chloride, CaCl2. I'm going to write that down because when we get into another chapter later on, we're going to be converting between different kinds of compounds. So it's a good habit to go ahead and get into writing down your formula for the substance mentioned. And it wants us to find the mass. So we're trying to convert to grams of the same compound, CaCl2. So we have moles. We know it's a one-step problem. We're trying to go to grams. So that means that our conversion factor is going to be our molar mass. So what I'm going to do is I'm going to come to the side, get my periodic table, and I'm going to calculate the molar mass. We have calcium and we have chlorine in this compound. So there's one calcium, and if you look on the periodic table, his atomic mass is 40.08. And we have 2 chlorine, so 2 times the atomic mass of chlorine, which is 35.45, and that's going to give you 70.90. So now when you add up that molar mass, your 40.08 to your 70.90, we're going to get 110.98, and that's grams per mole. Okay, so this is the molar mass calculation, kind of doing that over in a separate area. This is the molar mass of calcium chloride. Notice this units are grams per mole. Now, when you're trying to decide where your units go in your conversion factor, remember they have to cancel. So moles is here. I need to cancel it. So that means moles will go on bottom. And I'm trying to find grams. That means grams will go on top of the conversion factor. Also remember that in both Avogadro's numbers and the molar mass, the mole unit will always have a 1 beside of it. It's grams per 1 mole. Okay, so understood 1 mole. So I'm going to plug in the 110.98 on top then. So 110.98 grams per mole. That's your molar mass you just calculated. This is going to allow your moles to cancel, and you're left with grams, which is what you wanted. So what this means is I'm going to multiply, since these are side by side, I'm going to multiply 0.89 times 110.98, and then you're going to want to round that to 2 significant figures. So your final answer, when you round it correctly for this, will be 99 grams of calcium chloride. Okay, let's look at example 2. Example 2 says you have a bottle of lead 2 sulfate that contains 158.1 grams of the compound, and it says how many moles of lead 2 sulfate are in the bottle. So we see moles, we know it's a one-step problem. We see grams, that means we're going to need a molar mass as our conversion factor. Now again, this is going back to, we went over this in our notes under the section called helpful hints. So as we did before, we're going to always start with your given, 158.1 grams of PbSO4. Do the T-chart. And I'm going to come over here, and we're trying to go to moles. So we're going to put moles of PbSO4 over here. We need grams to cancel, so we'll put grams on bottom. And we need moles on top. That's what we're trying to find. And remember, 1 always goes beside of moles. Since this is my molar mass, I need to come over to the side and do the calculation. So again, you need your periodic table. we're going to break this molecule into its separate components: lead, sulfur, and oxygen. We got one lead in the formula, we got one sulfur in the formula, and we have 4 oxygens in this formula. So from the periodic table, lead's atomic mass is 207.20, sulfur is 32.07, and then each oxygen is 16 apiece. So this is going to give you 207.20 plus 32.07 plus 64.00. Okay, and I'm kind of squeezing that in there. Sorry about that, but running out of room. So I'm going to just write this answer over here. When you add all of these together, your molar mass for this is going to be 303.27 grams per mole. So this is the molar mass of the lead 2 sulfate. Now we're going to plug it into our problem here beside of grams. So 303.27 grams. Now this allows your grams to divide out. So notice we're going to divide since this is in the denominator. Our given has 4 significant figures. Our molar mass has 5 significant figures. That means we're going to round our answer to 4 sig figs. And so when you plug this in, you're going to get for your answer 0.5213. Now, the remaining problems underneath this column, numbers 3 through 8, are going to all be done following the same process. Okay, so we also talked about using Avogadro's number as a conversion factor. So that's what we're going to do on the second column. This says determine the number of atoms, underline that, in 0.58 moles of selenium. So we don't see grams, which means we don't need molar mass. We do see moles, 0.58 moles of selenium. And it wants us to go to atoms. Remember, atoms are the representative particle of any element, and this is just selenium. So we need moles on bottom. Remember, moles always gets a 1 beside of it. Atoms are on top. Avogadro's number tells us there are 6 times 10 to the 23rd of our representative particles in 1 mole of any substance. This is going to let moles cancel out. So we need to multiply by Avogadro's number. Now this is where it gets a little tricky if you don't remember how to plug in your numbers in scientific notation. Let me try to get my calculator screen here. So we're going to plug in our given 0.58. Now we're going to say times because we're multiplying by Avogadro's number. You're going to plug in your coefficient, 6. Now we're not going to plug in times 10. You have a special key for the scientific notation, and on my calculator I hit second comma, because notice I have my EE. I need to access the scientific notation function. So I'm going to hit second and comma, and notice this little E pops up. That means times 10. And now you're going to do your exponent 23. When you press enter, you get 3.48 e to the 23rd. That means your answer is 3.48 times 10 to the 23rd. But we do want to round to proper sig figs. So if you look back at your given, this has 2 sig figs, and Avogadro's number has unlimited sig figs because this is a definition and conversion factors have unlimited sig figs. So we're going to round our answer to 2 sig figs, 3.5, and then we're going to say times 10 to the 23rd for our answer. Number 10, 6.80 times 10 to the 24th formula units. Now it wants to know how many moles. So let's write this down, get our given. 6.80 times 10 to the 24th formula units of barium nitrate. Now since this does not mention grams, I do not need a molar mass. Since it does mention moles, I know it's 1 step. Moles needs to go on top. I need formula units on bottom. And remember, moles always gets a 1 beside of it. We know that there are 6 times 10 to the 23rd of our representative particles in 1 mole of any substance. This is ionic, and that's why they're called formula units. So we're going to divide. So watch me plug this in. All right, we're going to plug in 6.80, second comma, that's times 10 to the 24th.